So hi, how you guys doing? ขอโทษนะครับผมชื่อนาทีแสงรุจิเวชขอพูดเป็นภาษาอังกฤษนะครับผมเป็นเจ้าของ Makerspace Thailand. So ladies and gentlemen, if you don't mind, I'm going to speak this one in English. Yeah? So just bear with me. So today what we're going to talk about is what I call Innovation 2.0. What our role as makers are in the new era of innovation in this world. Okay, sounds good. But first of all, before I get into it, I just want to say thanks to Chiang Mai Maker Club and Ma Jimmy, wherever you are, for holding this event. This is great, yeah. I heard that there's over 200 people attending this event, so really awesome stuff. Looking forward to seeing the rest of the stuff this weekend. So, okay. We heard a lot today about makers, yeah, the maker movement. So, okay, great, but really, if we look in the whole big context of things, why should we care at all about what the maker movement is? Really, why? So, one thing that I watched that really made me care was this guy named Joy Ito, and he's the head of the media lab at MIT. Yeah, and on TED Talks, he gave this really wonderful talk that really put things in a really great context. And it goes something like this. Back in the old days, and we had the Industrial Revolution, and back in the old days, we had these huge monolithic corporations, yeah? And these guys had all the innovation in the world. You had to be a really big company in order to do any innovation, because innovation was very expensive. Yeah? That's the way it was. So we saw this ever since like the days of Ford, the automobiles, all the way up to what we call, oh wait a minute, here we go. But things started to change around this time. This was all before the internet came about. Yeah? The cost of innovation was super high. But after the internet, suddenly these big monolithic corporations, they no longer had a monopoly on innovation. So why is that? Because well, after the internet, we saw the cost of innovation went way, way, way down. Yeah? Suddenly, you don't have to be in a big company in order to innovate. You could be some guy in your dorm room. You could be some guy in your garage. All you have to do is program away, and then you put it onto internet. Yeah? That was innovation. So, in other words, the virtual world. So, the way that you used to make a company in the old days was something like this. You get a whole bunch of MBAs together, yeah, and you make a business plan, and then you go pitch to some VCs, and then hopefully they give you some money, and then you make a company. That's the way it was. But after the internet came out, everything sort of changed. Suddenly, you didn't have to put together a business plan and start trying to innovate, and hopefully someone will give you money, and then you can make your company. People just started making their companies. They didn't have to wait around anymore. So once they made the company, then they go, oh, okay, well, we have something going on. Then they can go to a venture capitalist who gives them some money, and then they can make a whole bigger company. After they do that, well, maybe then they'll hire some MBAs. So that's the sort of way that it kind of worked. And we know this to be true because, well, look, we saw this happen. Ever since the dot-com days, yeah, people suddenly started making companies, yeah. But then we had the Googles, we had the Amazons, and then after that era, then we had stuff that like Web 2.0, and then we had things like the social media. So we had stuff like Facebook come out and whatnot. Okay, great. We already know that this happened, yeah. We've already seen it. So what? What does this have to do anything about makers? Well, we're reaching a new era in this world. Before, on the virtual side, this is where innovation took place. Yeah? Cost of innovation went way, way down in the virtual world, and all these things happened. Well, now we're reaching this thing called what I call Industrial 2.0, the new wave of innovation. In other words, when the cost of innovation went way down in the virtual space, suddenly we're going to see the same things happen in the physical space. So, for example, like this is a factory over in China. They employ hundreds and hundreds and hundreds of people. Yeah? All these girls like poking away at transistors, putting things together. Okay, great. You have to be a big company in order to do this. Well, guess what? this isn't the way it is anymore. Now suddenly we have things like this. This is a pick and place machine. What used to be this huge factory in China, now it's the size of a car. This thing can put 20,000 circuits or components onto a circuit board per hour. This can replace a factory, and this can be placed inside of a little building like this. And what used to take millions and millions of dollars before in a factory, now suddenly you can get for something like $100,000. So that's what we're seeing. Or something like this. This is what was called the Sorona organism. It was made by DuPont. They took some bacteria that can go into like corn, and then what comes out is a polymer that can be used as a substitute for polyester. It cost them $400 million to develop. Again, the old monolithic way of corporations. Well, guess what? In the new era innovation, we see these things change. Suddenly, what used to be $400 million can be done by a guy at a desk, with this computer that can sequence genes, and it costs less than $1 million. From $400 million to less than $1 million in the span of our lifetimes. That's amazing. And this is what we're seeing happening right now. In other words, look, Industrial 2.0, this is where innovation lies. And again, we see the same pattern repeating. Low cost of innovation is happening now, not just the virtual space, but the physical. Things are now going to spread. It's not going to be a big company anymore. It's going to be us here in dorm rooms, in garages, or even places like this, in makerspaces. Because look, the makerspaces, we have all these things for people to play with. We see that the digital fabrication tools are becoming cheaper and cheaper and cheaper. We create these things so that we can bring it into the hands of the people. It is there for people to use. So, okay, great. So what? So what does that mean? Well, here in Chiang Mai, we started to talk to each other. We have the Chiang Mai Maker Club. We have things like Makerspace Thailand, based here in Chiang Mai. And we're like, well, okay, we have all these things at our disposal. What are we going to do? So now we're coming up with what we call the Chiang Mai Maker Mountain concept. Where we can all come together, and how can we use things like maker tools in collaboration together to make something great, make something new. So again, we have Makerspace, and then our partner, Space, and Maker Club, and Jimmy Software. We are all coming together, we are all collaborating together, and we're going to try to figure out what it is that we can do. So for example, like Makerspace, located over by Top Hat Gate. We have a huge workshop, several 3D printers. We have a laser cutter. Here's our studio room. In the back, we have our workshop. We have things like table saws and band saws and compound miter saws. We have all the power tools that you can use. We built our own CNC machine, so we can cut any material, up to aluminum, that we want. So we have Makerspace in our hands. We also have Space, which is by and large the most popular co-working space in Chiang Mai. Actually, if you look at the digital nomad list, Space is consistently rated as #1. So we have all these software developers coming by Space all the time. And we're collaborating with them. We're coming together and figuring out how, okay, we take Makerspace and we have Space. We mash these two things together. What is it that we can do? So in other words, all this, Makerspace, Space, Chiang Mai Maker Club, Jimmy Software, well, the Maker Mountain concept, we're making something called a venture building community. We're going to come together, pool our resources together, and create the ecosystem and the platform from which we can launch the next great innovations in this world. That is our goal. That is our aim. Okay, great. So there's the infrastructure. We have it all there. So what? How are you going to produce innovations in this world, right? You just have like a makerspace, you have a co-working space, great. Well, okay. That's where we start bringing in business aspects. For the last several years, I've been working in venture capital for a Singaporean venture capital firm. People come and pitch to me ideas all the time, and yeah, okay, great. But, you know, if we take our business acumen and start mixing in with the maker community, if we start mixing in with the co-working space community, what can we come up with? So we'll create something like Infinity Industries. This is an Industrial 2.0 company. We use innovation processes to create great new innovations. So some people are like, oh, okay, that sounds like an incubator, right? So you just go and make an incubator. And not quite. The thing is that what we found is that current incubators and accelerator programs, they just don't really work. Not really work, especially here in Asia. Look, I understand that this is what people do in Silicon Valley. I understand that this is what people like to do in the West. But the thing is, though, that the Western style of entrepreneurship, I feel, is not quite the right mix for here in Asia. Yeah? There's just certain key aspects. Let's just choose one. For example, like usually these incubator rates, at best, they have a 10% success ratio. Yeah? At best, they succeed 10% of the time. Y Combinator, one of the most famous ones in this world, right? Their success rate is about 7%. Yeah? And that's one of the best ones. In other words, they have something like a 90% fail rate. Well, remember what I said, doesn't really quite work, especially in Asia. The thing is, here in Asia, we have this whole entire concept of face. Yeah? And that's something that Westerners, they don't quite get. Like, we have this whole concept of face. So when we screw up, people will remember that for a very, very long time. They're not going to be, oh, okay, you failed. That's okay, just pick yourself up and keep going, keep going. No, our society doesn't run that way. When you screw up, people go like, oh, you're the guy who lost me $10 billion. I'm going to remember you for a very long time, and I'm going to tell a whole lot of other people, this guy lost me $10 million. Yeah? That's the way it works in Asia. So let's not copy what we see in the West. We need something new, something different. So with Infinity Industries, we want to solve this problem. So something like this. So what we have our hands on is an innovation process that has been scientifically proven that we have a 50% success rate. From what used to be a 10% success rate, we can get 50% success rate. Now I know it's not 100%. Yeah? I can't promise 100%. That's ridiculous. But okay, 50%, that's a whole lot better than 10%. So okay, we're going to run this, and we're going to run it within the Makerspace, and also within Punch Space, within Maker Mountain. So this is what we're going to bring to Chiang Mai. On top of that, not only do we need to have the process, we also need to have a place to test it. It's not enough that you create something. You also need to rapidly prototype. You need to be able to get out into the market and test your ideas all the time. Well, thankfully, here this is, for you out-of-towners, this is Chiang Mai Walking Street. Happens every Sunday. And yeah, there's thousands and thousands of people that walk by all the time. And guess what? Oh, well, look, we're right here. Yeah? So all the new innovations, all the new ideas we have, we can just walk out onto the street. We have the space already. We already have permission from the landowners. Oh, by the way, their family invested into us. And they've already agreed that, well, look, okay, we can test easily with all the people who walk by. They're from all over the world. We have something we can walk out and say, oh, okay, well, what do you think about it? We don't have to necessarily sell it to them. We just have to give them a look at it and get their feedback. That's the most important thing, especially when we're talking about groundbreaking innovations. So, and yes, we are right here. Okay, great. But what does that all mean? Well, let me give you some examples. Like, one thing that we're looking at is, okay, for example, how can we hear something like Clubfoot with something with Maker Tools? Now, maybe you guys don't know what clubfoot is. Clubfoot is where, this is a normal foot over here when a baby is born, but clubfoot is when their foot is born and it's like all crooked like this. Yeah? And the thing is that about 160,000 kids per year, they are born with clubfoot, and most of them are in the developing world. Only about 5,000 of that's in the developed world. Most of that is in the developing world. And quite honestly, most of these kids, they never get treated. Yeah? This is a 100% curable disease, but most people don't get cured. In fact, most of them don't have a chance to be a contributing adult in society. They grow up and they look like this. Yeah? This is what happened. This is a guy from India. Yeah? He never got treated. And this is what his feet look like. And it happens all through the developing world. Well, okay. So how do you cure it? Well, one guy, this is Dr. Ponseti, and what he created was this system by which that 99.5% of the time can cure clubfoot. Yeah? It involves you taking a whole series of casts. Here we have a baby's foot, it's deformed, and through a series of casts, you do it once a week, and eventually the clubfoot will be cured. It takes somewhere between 6 to 8 weeks to do it. The thing is, and it's great and all, it's plaster cast. The thing is though, is that it's very, very time consuming. It's a real pain in the ass. I come from a doctor's family. My aunties are doctors, my uncles are doctors. Heck, my mother and brother are pediatricians. They look after babies. And they're like, well, look, doing the Ponseti method is a really pain in the ass for a doctor. Doing casts takes a very long time. You're looking at something between, 35, 40 minutes of just sitting there wrapping a kid's foot. And on top of that, the kid doesn't cooperate. The kid's a baby, yeah? Likes to kick and scream, so you have to hold them down. Yeah? On top of that, it's a very messy process, so it's not enjoyable for a doctor at all. And it's made even worse when you have kids with 2 feet that need to be done at the same time. So okay, so how do we fix this? So originally we're looking at more traditional methodologies, okay, maybe we have an exoframe, that we can do on someone's foot, or maybe we can look at a cast system, and the thing is though that, okay, although these technologies are great, they're not always feasible. In fact, a lot of them are pretty expensive. And remember when we said 90% of the cases happen within the developing world, they're not going to pay $500, $800 to fix clubfoot. They can't afford it. Yeah, that's why they're using the cast system in the first place. But these things are slow, and these things are messy, and they're unenjoyable for the doctor. So we couldn't pursue this. So, but after some time we go, well, then we became aware of something. So here's a 3D printer that we found up on Thingiverse. Some people who actually created a wrist brace made out of PLA plastic. All you have to do is boil it in water, and then it conforms to your wrist. So, that's pretty interesting. The thing is though that PLA, the temperature in which it turns into glass transition, where it gets all soft and whatnot, that's about 80, 90 degrees where it starts getting soft. And that's Celsius, by the way. So you're going to tell a kid that has their foot in this thing to withstand 80, 90 degrees, they're going to burn their skin. So, okay, we can't use PLA. But at the Makerspace, we come into contact with a lot of cool stuff. People bring in stuff all the time. And one guy, he brought this stuff in. It's a medical grade FDA approved thermoplastic. Yeah? All it does is, all you need to do is pour some warm water onto it. Yeah? Let it sit for a bit, and it turns elastic. It can start bending. Yeah? It becomes nice and soft. To lock it into place, all you have to do is pour some cold water on it, and suddenly it just holds its shape. Oh, that's pretty interesting. And then all you do from there is when you want to readjust it, you just take a hairdryer, blow on it for a bit, and then it turns soft again, and then you can reform it to whatever shape you need. Oh, that's kind of cool. So, what can we do with this? Well, it just so happens within the Makerspace we have this huge laser that can pretty much cut through anything. So we're like, okay, well, let's start experimenting with this new type of polymer. And then we started experimenting. On the left there, you see what we had originally in the PLA plastic. And then through a series of processes of prototyping, then we come up with a rough prototype and start refining and refining. Yeah? So we start exploring, how can we use the thermoplastic? Now we don't have to print it anymore. Now we can take a thermoplastic and cut it out, and it becomes soft at a much lower temperature, yeah, that doesn't burn the skin. Okay, great, that's a wrist brace. Then what? Then, okay, then it becomes a simple process of us now. We go to our little laser cutter, yeah, and cut out the thermoplastic, and then now we can start putting it onto people's feet. Well, here we use a bear as a simulant, yeah, my little teddy bear, yeah, but yeah, it works pretty well, yeah, and now suddenly this thing can hold its shape. Yeah, and then you warm it up, then you can readjust the feet. Now suddenly what used to be a half an hour, 45-minute process for the doctor per week for 6 to 8 weeks, now the follow-up is something more like 5 minutes. Yeah, and no more of this trying to hold the baby down and whatnot and having your hands all messy. Now suddenly you can just slap it on when you need to make an adjustment, put a hair dryer on it, readjust the foot and lock into place. So yeah, pretty good. So that's patent pending, and then our next step is to go into clinical trials, yeah, start putting onto babies, not just teddy bears, yeah, and then start pumping it out. We're going to put it up on Kickstarter or some other crowdfunding source, yeah, and suddenly we're not asking people to, okay, buy a laser cut cast for themselves. Now it's suddenly, well, okay, you don't have to buy it for yourselves, but you give us $50, yeah, and we'll send this, we can put this thing in an envelope and we can send it to anyone in the world that needs it. Right? So suddenly, no. Now we're talking about how can we use crowdfunding, how can we use things like Kickstarter to do social good for the world as well. And this all comes from using the Makerspace and using the Makerspace tools. So that's one example. Yeah? Here's another example. So this is what we call IOTA. Yeah? IOTA stands for the Internet of the Air. Yeah? And this is what we're producing right now. And it all comes from a trip that I had several years back. Yeah? You guys might recognize, oh wow, that's really dark. So when I visited China, or Beijing to be specifically, like about 7, 8 years ago, the air there was terrible. Horrible. And the thing is that the Chinese government would never tell us what the air quality was back then. They say, oh, everything's fine. Yeah, the air is not bad. But we look outside the door and, oh, we know it's bad. And the only thing that allowed us to have peace of mind of how bad the air was on top of the US Embassy, they have this air sensor that sends out tweets all the time that tells us, okay, over here, this is the same shot, by the way, but this is on a clear day, and this is on a typical smoggy day in Beijing. Yeah? And it would tell us, okay, this is what the air quality is like. Oh, that's pretty good. So, and we think that this is applicable to all over the world. I mean, just the last week here in Chiang Mai, looked something like this. Yeah, that was not very enjoyable. It even prevented airplanes from taking off and landing. So yeah, and we had to breathe that stuff. Not so nice. Over here, this is Singapore. Yeah, and this happens as the Singaporean contingent told me last night, around June, July. Yeah, every June, July. This is what Singapore looks like. Yeah, so not so great. So okay, so what can we do? So, okay, well, we're a Makerspace. So here we have some electronic components. We throw it all together, and now suddenly, okay, here we are. We have up here on our Twitter feed, we tweet every 5 minutes what the air quality is like here in Chiang Mai. It gives us accurate reports. Our sensor is located over there in Niman. From there, okay, once we have the hardware, then what do? Then we go to people like, I have a friend over at Blizzard Entertainment, and he agreed to do our UI design for our application, so that now, like, if you say you want to go for a run, yeah, all you have to do is look at your app, and it will tell you how bad the air is. So, okay, it will even tell you in real time, okay, maybe I don't want to run this way, maybe I should take a different route, because the air over there is really bad. Or we can even put these things in things like schools. Every year there's a new school being put up, and for some reason they like to build them next to freeways. That's horrible. There's so much air pollution next to a freeway, and yet they're putting up schools. And why? They can get away with it because there's no way to measure air quality. With something like our device, now suddenly we can put these up in the schools, and you can see whether or not you really want to send your kid there. In fact, air quality is a huge, huge issue. I mean, there's more people that die from bad air every year than people that die from smoking. There's 6.3 million people that die from smoking per year. There's actually 6.8 million people that die from air pollution every year. This is kind of a big problem. Okay, so we have the UI design. From there, we actually started bringing in other people. My friend Jeff back there, he agreed, once he saw what we were doing, he agreed to do our industrial design. So now we're starting popping this out. So now we have the IOTA station with industrial design, where we start looking into how can we start integrating in and making it look good like solar panels. This is how we try to attach it. This is how we try to do all the assembly. From there, then we started bringing in other people. So we have people like Jimmy Software, where they have a company here in Thailand called Big Data. So now suddenly we can start collecting all the data that comes from our sensors and start analyzing it. Yeah? In fact, the more sensors that we have, the better. In fact, what we want to do and what we're proposing to do is create the largest distributed air sensor network in the world, that we can collect the data and we can analyze. So what does that allow us to do? Now suddenly it's not only about how can we make clean air, yeah, but now we can start addressing bigger issues like this. This is Al Gore from The Inconvenient Truth, yeah, and he talked about global climate change. And nothing has happened really in the last 10 years. People are still arguing over it. Well, with something like IOTA, so now we have the ability to put an end to this whole entire climate change debate once and for all. We will have the data, we have the ability to analyze it, and we'll be able to put it out into the public. And again, yes, once we have everything prototyped out and we test everything out, we'll put it up there on Kickstarter or whatever other crowdfunding site. People can buy our sensors, yeah, and that will help support the effort. Yeah? Or you don't even have to buy the sensor, you can just buy the app. Yeah? In other words, you do these things and then we can help save the planet. Or, as I like to put it, put the power of the planet in our hands. And that's what we're proposing with IOTA. And these are the things that we're doing at Makerspace, and this is just the beginning. Yeah? Here in Chiang Mai, the collaboration between all of us in the Maker movement, this is what we're hoping to accomplish. And we're just going to come up with better and better stuff all the time. This is just the beginning. The best is yet to come. Oh, and one more thing. When people like talking about crowdfunding and whatnot, what we found is that, well, it's hard to do manufacturing, so what we've taken great pains to do is we've been finding low cost, low volume, and honest manufacturing. I know you can go to China, I know you can produce things there, it's really cheap, but quite honestly, you produce anything in China, chances are they're going to steal your idea. Yeah, they're going to copy it. The next thing you know, the next day, the next week, you're going to see the exact same thing that you made on the street, on the sidewalks of Shenzhen. That's the truth. So for here, us in Chiang Mai, we're going to evolve more than just a makerspace. We're also going to look into microfactories. Yeah? We're going to expand, so we do low volume production. We already have people in place. This is Volker. He's a good friend of ours. Yeah? This is his factory. Yeah? He has injection molding machines. He can produce things for us. Oh, you know that thing that I said, the pick and place machine that replaced the Chinese factories? Well, we have access to one. He has one. He's already agreed to do it for us. Huh? So no problems. This is Richard. Yeah? He has a huge CNC machine. He has made this available for us so we can cut things out. So this is Chiang Mai Maker Mountain, a collaboration between all of us. And I would like to say to all of you here, right now, people who are interested in the maker movement, anyone, you are a school, you are an entrepreneur, you are a maker, you're a scientist, we invite all of you to come and join us. We are an open platform. We want to help you. We want to collaborate with you. So please come see us. Please talk to us. Yeah? So, yeah? And this weekend, yeah? On Sunday, 4 p.m., we have free beer and food over at Makerspace. We have the open house. Starts at 4 p.m. Yeah, we have tons of parking. Please come. Don't come too late because remember, we have the walking street right next to Makerspace. So the traffic will be really bad if you decide to show up at 6. Don't do that. Show up at 4. Yeah, come and check us out. It's all sponsored by Chiang Mai Creative City. We have a map, and I believe we have maps over here as well. So if you need to know how to get from here over to Makerspace on the other side of the moat, please pick up a map, yeah, and come by and see us and check out our spaces. Thank you very much.